Hello, ladies, gentlemen, and in between, and welcome to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today we're going to get into some real Year 12 maths, and I say that because the stuff we've been doing so far, like indices and surds, that's probably been kind of like GCSE revision for most of you, or maybe not the proof, but pretty much GCSE revision so far. But today we're going to introduce the first bit of what I like to call real Year 12 maths. Now, you've probably heard of these things before. They're the most important mathematical object you'll ever learn about, and I say that because they're just incredibly pervasive throughout all sciences. They're so useful in physics, statistics, biology, chemistry, so many other fields, and they're called functions. Now, you might know what a function is already, but even if you have, stick around because it's probably going to be a very useful video for you. And you know, I bet that I think they're so useful, and I think it's so important to do this video because I'm willing to say that all but one of the chapters in AS Maths are dedicated to the study of specific types of functions, including this one that we're going to do now. So, without further ado, let's get into it, shall we? Okay, so let's get started. Basically, I'm just going to tell you what a function is. So, a function is a mathematical object that you can put a number into it, and then through some kind of algebraic process, it will transform that number into something else. For example, your function could be a double and then add one function. So you input a number and it will double it and add one. Or it could be something way more complicated, like you could put in the number of years since a rabbit colony started, and it will tell you how many rabbits have been in the population since then. So functions are incredibly useful, and you can see them like that. Now, an amazing visual way to represent functions, which I've drawn up here, are as machines. So if you ever get confused and you forget really what a function is and you get lost in the source, then this is a great way of visualizing it. So imagine a function as a machine. For example, I'm going to use as a concrete example the doubling and add one function. So imagine you put in 2 to this function, then what you're going to output here, and look at this notation here. So this f of x is a mathematical representation of what we mean by a function. This just means a function acting on some general number x. And as I said, I'm going to use the doubling add one function. So if you shove in 2 into this function, you'll get f of 2, which equals, well, 2 times 2 plus 1, it equals 5. Or, for example, you could just shove in a negative a half to this function, and you'll get f of negative a half, which equals a big lovely 0. But in general, if you put in any number x, real, rational, integer, irrational, doesn't matter, you'll end up with f of x, and that will equal 2 times your input plus 1. And now, that is the algebraic way of representing a function, because, maths, if we don't have a way of algebraically representing our ideas, then really we can't really do maths with them. So that is an algebraic way of representing a function. You just write out what the algebraic process is that it does. Now, let's get into some examples of some more types of functions, shall we? Okay, my boys, these are 2 different functions that I can introduce you to. This first one up here, everyone's favourite function, is really nice for doing examples with, which is why I'm using it here. And this is the function such that the number you input into it, it'll output that number squared. For example, if you input 5, you'll get out 25, which equals f of 5. Sorry if you can't see that, that's kind of small, but yeah. Now this function could represent anything. For example, it could represent the area of a square. So you plug in the side length of the square and it will tell you what the area is, or any number of crazy things like that. Or you could have a bit more of a complicated function. It'll take a second to digest what that means. F of x equals 2 to the x. So whatever number you input, your function takes 2 to the power of that number. For example, if you input 4, then you're going to get f of 4, which is the same thing as 2 to the 4, which is 16. Or if you want to use the exponents revision, remember that I taught you last time, you could have a note f of negative a half, which, arrow, this is a really long arrow, right? F of negative a half, you get 2 to the negative a half, which if you use some of the exponent rules, that equals 1 over the square root of 2. And of course, this function here could represent like the rabbit colony again. For example, if you plug in 3, that could mean, 3 hours after the rabbit colony started, well, you've got 2 to the 3, which is 8 rabbits in the colony. Now, there's different ways of naming different types of functions, because there's so many different types of functions, so many different types we're going to study, trigonometric, exponential, blah, blah, blah. This is an example of an exponential function, because it raises your input to the exponent of a number, so it's an exponential function. And this is called a polynomial function. And my boys, a polynomial function is pretty much the entire thing we're studying in this chapter. It's the specific type of function that we're studying. And with that little knowledge there, let's get into what a polynomial is in a bit more detail. Right, okay, my friends, now you know what a polynomial function is. Well, kind of. Now you know what a function is, it's time to learn specifically what a polynomial function is. Now, a polynomial function is a polynomial function if it consists of, well, just taking your input number and raising it to a positive integer power and then adding and scaling by numbers. So for example, look at this top one here. We've got f of x equals 2x minus 20. So your number gets multiplied by 2 and then you subtract 20 from it. And you can see that this is definitely a polynomial because, well, this is just raising your number to the first power, and 1 is definitely a positive integer. So that counts, ding, that is a polynomial. Big tick next to that one, my boys. Now this one here, this is a bit more complicated, right? This squares your input, which can introduce some funny stuff, and then it subtracts 32 times your input plus 5. Now you can check for yourself that this is definitely still a polynomial because you've got your input raised to a positive integer power here, squared, and then you've still got you're minusing 32 times your input raised to the first power. So all the powers are positive integers, so this is also a lovely polynomial. Now this one here is even a bit crazier. It takes your input to the third power, that's pretty wild if you ask me. And then it subtracts 12x squared plus, that says 5x. I'm really sorry if you can't read that. I've got really shoddy handwriting, everyone tells me that. But yeah, so this still definitely counts as a polynomial because all we're doing is raising our input to whole integer powers and then adding them and then multiplying by numbers. But, put it next to that one, but this one down here, it may look like a polynomial at first glance because you've got x squared here and that's a positive integer, but you've also got this plus square root of x, which is a bit pesky because if you recall, the square root of x is the same thing as x to the half. If you don't really remember that, you can watch my video about exponents division. Shameless plug, right? And a half is definitely not a positive integer. It's not even an integer. So this is not a polynomial, put a big cross through that. So now we know what a polynomial is. There's even different types of names for polynomials. Now, this one up here is called a linear polynomial because its highest power is 1. And that's how you distinguish between different types of polynomials. You just look at the highest power your input gets raised to. So functions such that your input gets raised to just 1, those are called linear polynomials. They're called linear because when you graph them, I'm sure you're familiar with y equals mx plus b, you just get a nice linear straight line. These ones here, where you get the highest power of 2, those are called quadratic polynomials, and I'm sure you're very familiar with them from GCSE, or you hate them, depending on how your experience with maths goes. So these are called quadratic polynomials. Lovely jubbly. And these ones here, these will definitely be new to you, unless you've done some further reading, very much like that. These are called cubic polynomials, probably for the good reason that their highest power is cubed. And these are the new beasts you'll be studying in AS Maths. They're really cool, lovely. These two, you're probably very familiar with GCSE, but this is the new thing we're going to be studying. And you get a lot of interesting things, a lot of painful things to learn, but don't worry, it's going to be a wild ride with your boy Hamblin. And wait, let me just write cubic here. This is a cubic polynomial. Right, and another thing, another way of categorizing them is this is a degree 1 polynomial because it raises its power of 1. This is degree 2 and this is degree 3. So, my boys, that is the different types of polynomials that we're going to study in this chapter. And there's so many lovely things to learn about them, like the factor theorem, like roots, like graphing them. Their graphs look so good. Now, we don't study past cubics because honestly, stuff beyond those is a bit unwieldy to deal with. And if you're curious, by the way, it goes then quartic, quintic, and I actually just don't know the names after that because you don't really need to. Anyway, those are the 3 different types of polynomial functions we're going to deal with this chapter. Right, so let's get into the summary and then I'll be on my way out. So, in conclusion, my amigos, a function is just some mathematical object that you can give it a number and it'll do some crazy algebraic process. Doesn't matter what that algebraic process is, how insanely complicated or simple, it will output another number. Now, they could represent something simple like doubling or +1, or represent something useful like plug in the amount of years since a colony started and it'll give you the population of that colony. Now, there are very special types of functions called polynomial functions, and these are functions that the only thing they do to your input is raise it to some positive integer power and add and multiply by real old normal numbers, my friends. And we learned that if a polynomial function has x to the first as its highest power, that's linear, x squared is quadratic, and x cubed, is a cubic polynomial. So that's pretty much it for today. Sorry, this might be a bit of a short one, or you might have known this already, but even if you did, I think it's very valuable to know what functions are and get very comfortable with the nomenclature towards them. So, and remember, if you ever get confused, just think back to the machine analogy. I find it very useful to teach people, if you ask me. So anyway, that's been this episode of Maths with Hamblin. If you liked it, smash that subscribe button and that like button, my boys. And I'll see you in the next episode. Bye.